I'm Cailin. I'm in marketing with DataXstream, and today we have Juichia Holland with us. Juichia did a internal presentation earlier this fall that was really interesting about a project that she's been assigned to work on to meet some customer needs with OMS Plus, which is one of our products at DataXstream. So since that internal presentation, we've decided to go ahead and kind of tease out and let people know what we're working on because it is really exciting, and give her the opportunity to give us an overview of the project as it began and kind of where she is with it. And so Juichia, if you want to introduce yourself really quickly and just explain your background, and then we'll go into the overview.
Hi, I'm Juichia, and I've been working in SAP for 15 years. I started doing integration with DataXstream and then moved into PI and CE and did some software development. And last year I transitioned into data science and artificial intelligence because I think it's a very exciting field. So this is my first kind of industry project. So I'm very excited about it.
It's really exciting. So you kind of showed us a slide, and I don't know if I gave you screen share.
You see it?
Yes.
Is it this slide or?
Yes. Yes. So I just thought was a helpful visual of kind of what the overview was that we're working on, or that you're working on. To kind of explain the overall project and process, and then we could get into, what that means.
Okay. So we're bringing machine learning and artificial intelligence into OMS Plus. And the first customer requirement that we have is with regards to matching material descriptions from customer requests into SAP system. So in order to design a solution using machine learning for this requirement, we are using data science to kind of scope out the data that we have and the possibilities in machine learning that we have. So data science takes through a pipeline of steps with the data from the customer, and the first thing that we do is to source the data from the customer, usually from their database. And then we take that data and we wrangle with the data, which basically means we remove the duplicates, we check if the data is valid, we format it, and we kind of make everything ready for the machine to learn from. And then that transformed the data into information in the exploratory data analysis step, where we kind of do some initial statistical analysis on the data, like finding out about the number of words in the descriptions, in the material descriptions, the number of characters in the material descriptions, and other information like that. And then from such information, we can formulate hypotheses about the data and about the problem that we have at hand, which we then move into feature engineering, which is a step in data science where we generate additional features out of the data that we have. So for example, we might, with material descriptions, we might make another attribute about the description, like number of words in that description or number of characters in that description, or the similarity score of between the descriptions. So in feature engineering, we make these additional features, which we can then use in the final step of statistical data analysis, where we use statistical methods to analyze and to confirm the hypotheses that we have come up with in the prior steps.
And there were a couple interesting things when you did this on the internal presentation that sort of stood out to me. And one of them was that just because I have however many years of working vocabulary, and I will say this is relevant to this, that's something that you actually have to teach the system based on each customer's database, right? Like, so in one customer's database, there's relevancies between certain words or certain similarities between certain words that should show up in a search. And that's going to be independent to each customer.
Right. So when the customer sales representatives perform a search based on a customer requirement, for example, their customer have asked for a pipe, and that representative, maybe because he has worked with that customer for a long time, that he knows, oh, this customer, when they ask for a pipe, they actually mean this tube or this gauge in our system. And that's the material that I need to pick from our SAP system. So they base it on when humans do it, they can know immediately what is relevant based on experience. But the machine doesn't know what is relevant unless we give them that data. So to start with, we have to be able to convert the data into numerical features so that the machine can use to determine if a customer request, how similar it is to an SAP material. So it can, to begin with, it can only use these sort of numerical scoring and comparison to understand the data. But going forward, what we hope to do is to be able to engage, once we layer in the first machine learning solution, and we can kind of engage sales representative feedback about whether the search results we are presenting to them are relevant or not, then we can give that information to the system, and the system can use that to learn about furthermore about the data and make more accurate predictions.
And so for this current project that you're working on, when I first listened to the presentation, I imagined sort of more of like a self-service scenario. But when I was talking to the OMS Plus team about it, they said, no, this was actually for a customer who receives large bids or a request for a bid. And so they have to go out to, their customer will maybe ask 4 different people for a bid, and whoever gets all of this, the product organized and can give them back their quote, usually within a timely manner. That's one of the biggest parts, right? And then 2, obviously, of course, competitive price. So that we're using this for the customer reps to be able to, in a timely manner, go out and gather a quote on a variety of different needs for their customers. Is that?
Yeah, I think currently what they're doing is the sales representatives are receiving lists of material requests from customers that are usually in spreadsheets. And
Okay.
these material requests, the materials are described in from the perspective of their customers. So they're in no way matching with the SAP systems materials. So that's kind of the scenario they're going through right now, where the sales representatives have to now take this Excel spreadsheet and make a manual mapping of the requests to SAP materials.
Okay.
And some of the unique challenges there are, for example, there are scenarios where the customer request in no way matches the SAP material. So it's completely, when you score it from a similarity perspective using the system, the similarity score between the matching pairs is actually 0. So that's kind of a unique challenge for this search engine that something like Google doesn't have.
Right. Wow. Okay. So, and then I have lots of like random questions, but not knowing anything really about data analysis or machine learning, I'm assuming that once we get the first few scored, and not scored, but aligned, where they say, okay, this description equals this product in the SAP database, that will start to create information that the machine will use to start putting things together.
Right.
Does it work like that?
Yes, exactly. So that going forward, the more data we gather about the descriptions and the matches, the more the machine can learn from the data and be
Okay.
able to be more accurate in the results.
So it should get faster.
Yes.
Because it sounds like at the beginning with the data wrangling, that's a really long, sort of tedious process.
Yeah, so right now we've already gone through the data processing pipeline for the material matching solution. So we've taken the customer's SAP material data and we've gone through data sourcing, wrangling, the analysis, feature engineering, and statistical data analysis to do hypothesis tests. Well, and now we're into the phase where we can take what we know from the data science work that we've done and implement the machine learning solution. And the solution we're using right now implements a very common search engine method called TDIDF,
Okay.
which is using basically transforming the material descriptions into vectors of numbers based on the term's frequency and term importance, and then be able to compare these vectors of numbers to come up with the similarity scores.
Okay. Um, and so that's where we are now, right? And then what do you envision as sort of like the next step along the way? Because this is obviously.
From a machine learning perspective, the next phase that we're going to implement is we're going to try and engage user feedback into the pipeline. So once the user is presented with search results, they will be able to have the option of providing feedback on whether a result is relevant or not.
Okay.
And then we can gather that data and be able to use that to improve the solution.
Okay.
But from a infrastructure perspective for machine learning, we're looking at partnering with SAP to use SAP data intelligence and bring our data processing pipeline into the platform and then connect directly to SAP HANA database so we can have an end-to-end solution for machine learning and be able to deploy these solutions directly using data intelligence and connect to OMS Plus.
That is super exciting.
Yeah.
That's really, really exciting. I can imagine many of our customers will be very excited to see that become available to them through OMS Plus. So I think we're going to wrap this up here for today, because I think, we've kind of covered a good little bit of what you're doing, and then we'll touch back with you in a couple of weeks and kind of hear where you're at.
Okay.
And we're just going to kind of keep bringing this out and letting people know how this project's going, because it really is an exciting project and we really do want to let people know about it. And this is fun. Thanks, Rachel.
Yeah. Thank you, Cailin.
All right. Take care.
Okay. Bye.
Bye.